Today, I'm just going to cover more like the transport layer and network layer. I know this is kind of a bit technical thing, but we are now going in details technical thing because of non-IT background and because of the level of course it's all about MSc IT. It's not a cyber security, it's not advanced computing, it's not IoT, it's not a blockchain. So definitely, also information technology is all about this fundamental thing, the basic thing. So I will just cover all about in terms of the basic level so everybody can understand. Yeah. So what we are going to do today, so it's all about, we did application on the top of the level and the lower layer, the physical level, everything in data link layer, we did it. Now we are just simply covering these two layers, the transport and network. Why we are not finishing all the OSI model? Because, OSI is a, like, old kind of technology. So this is internet model. So recently this is working. So we did this thing, we did this thing, we done this thing. Now we are going to finish all these 5 layers. So definitely, so transport and network, they are trust me, they are more likely connected with each other. Transport layer, as we say, this is layer 4. Please make sure you need to mention like, which is level 1, which is level 7, which is level 4, something else you need to know all about carefully. Level 1, level 2, or layer 1, layer 2. These are very, very important in networking. The transport sits like, the layer 4 segmentation, and this is providing like different thing, like it's responsible for transmission, responsible for conversion, responsible for segmentation, responsible for applying the ports and kind of all these things. So we will discuss about a network layer is kind of responsible for, this is layer 3 if we count from the internet model. This is all about the responsibility. So providing like encapsulation, error handling, providing source and destination, all these things. So we will go like, routing table, decision table, logical table. So we can simply say, this is responsible for logical IP addresses like IPv6 and IPv4, something like we will cover here. And this is all about, the TCP, UDP, kind of, the ports allocation, segmentation, end-to-end conversion, these two things. So we are covering in a little bit more detail, yeah. And this guy is just handling, providing routing for, let's say you watch YouTube video in YouTube London. So what will happen? The routing table, routing algorithm, they will find a easiest path for you. Maybe from America, maybe from Europe, depends like, which is the easiest path to deliver to your video recording, video thing, something like this. Yeah. So let's talk about the TCP IP is all about, the very one of the important communication of fundamental communication protocol instead of like also intranet and extranet communication. Once the host and senders are communicating with each other. Without TCP IP, that possibility is zero. So we can't connect, we can't receive, we can't upload, we can't download anything. Yeah. Either it's intranet, either it's extranet, either local area, it's a wider area, it's a backbone. Wherever we are, make sure TCP IP plays a very, very important role. So please make sure you can run Wireshark so you can capture these packets later on. Yeah. So let me finish very, very simply and very, very quickly. Let's say, as I say, the transport layer. Transport layer. So let me show you the transport layer. Once we talk about the transport layer, very, very important. So the one of the fundamental and most common transport layer protocol is the TCP, transmission control protocol. TCP is a very, very important protocol in transport layer. So let's say we are here. So I said TCP is being used here. UDP is being used here with the help of sessions management. So let's talk about this thing. Yeah, I think we have discussed this thing. Maybe before the MCQs class test. So I was taking class test 1 year before with a short question with long question. So I was always sorry. Yeah, please turn off the microphone. Will be better. Yeah. So I was using short question, long question. So I was giving long question, especially from the TCP UDP protocol. Something right now, this is not case. So everything from the class test will be MCQ. So you don't need to worry about it. So, okay. So, but again, make sure there will be MCQs related to transport layer. Normally TCP, normally UDP. So you need to know about it. So that's why I'm asking. So please be careful. Yeah. So transmission control protocol. Very, very simple. As I said, it's very important. Why? Because it's using 3 handshake connection. 3 handshake, if we say like, sync, acknowledgement, like sync, and acknowledgement, something like so. Once internet is communicating, sender say, oh, I have got something for you. Receiver say, okay, so send me. So it will send some sync acknowledgement. Once the packet is sent, so it say okay, acknowledge, like sync acknowledge, something like so. Three handshake creation of connection. We say this is session. So we say why there are three parts of connection: sending, getting confirmation, because TCP is one of the connection oriented. We say connection oriented because of its using a reliable, secure connection. We need a proper security, reliability. That's why we say a connection oriented protocol. Whenever you are using emails, whenever you're using transaction, paying the fees to UWA, searching contents from OLAP, so all the important things. So they need a reliability, a security. Whenever we are using the same thing, so we are using TCP connection because we need all the safety, security, and make sure TCP is reliable, make sure TCP is a three handshake, make sure TCP is a more safe and secure, and make sure this is one of the slowest as compared to UDP. So we can come to discuss. Okay, don't worry about it. So let's say, so this is a like the packets representation, that kind of the data representation. If you can check, there are some acknowledgement, header, some bits unused, some flag, some control bits, some like cyclic redundancy, some pointers, lots of things. Why? There are source, destination, plenty things. If we can check in on UDP, UDP is very simple. There is no CRC, there is no three handshake, there is no source and destination thing more likely in detail. So we can check the complexity or the the configuration of the UDP, user data protocol, is less as compared to TCP because TCP is using more security, more reliability, more connection.
Sir, you are on mute, sir.
Sir, we lost your audio.
Yeah, sorry, yeah, I have a flu, so I muted myself. Just a minute, thank you. Thank you so much. Yes. I will continue. Sorry. So TCP is all about security. So please make sure whenever you are accessing web pages, emails, transactional things, current things like you are paying something, making transaction to your home country, your friend, family member. So this is all about we are using TCP layers. Make sure this is very, very important. Yeah. Whenever you are using a YouTube video, YouTube needs a massive amount of data to be loaded. Let's say you have a 100-inch screen, you have a mobile phone, and you want 4K or 8K resolution. So what will happen? So your server will utilize UDP, user datagram protocol, more likely, the audio, more likely video. So we are using less security, less cyclic redundancy checks, because if we are using lots of calculation like the TCP, what will happen? The 4K video, we will not be able to watch it. So we can't listen voice from America to Europe within a second. So that's why, these complex things, they are going to check it and reduce the internet speed. So UDP is not using all of them. So we say a user datagram is connectionless, and we can say that TCP is a connection based or connection oriented. It can never lose protocol packets, so it can lose some packets. You know why? Because data is too much in the details. Heavy data, you can say 4 gigabytes, 8 gigabytes, they can transfer easily, no problem. And they are using space. If they need a security, especially UDP, normally, so this guy, the transport is not applying any security. Only security is coming from application. If you are using UDP, so application is applying some security, like your browser, maybe some endpoint security, maybe some encapsulation, VPNs, all these things. So you can apply over here. Yeah? This is all about the UDP. So please make sure you need to know there will be some question in your class test TCP UDP. For KR transmission, UDP, no need connection, no need security, no need handshake. That's it. Yeah. Let's finish now. Rish. Okay, so in internet, so we have different IP addresses. So you might have heard like different IP address, IP version 4 and IP version 6 here. So let's say we are on a globe. Currently, we must be plus 7 billion population almost. So maybe the internet users, they can be more than 7 billions right now. So before a long time before, the network technologies, they were using only IP version 4. IP version 4, 32 hexadecimal addresses. So 2 power 32 was equals to nearly, half, 4.5 billion possible thing. I told you before, IP address can never be similar. If there are 5 billion people, they must be separate IP addresses. So that's why, IP6 was not able to support the 7 billion users devices. The users are more than 7 billion. But IP4 cannot support the 7 billion users combination. So what happened? The scientists developed IP6 version 2 power 128 hexadecimal notation. So which is like, enormous. 3.4 into 10 power raised 10 raised to 38 possible. Can you imagine how much this is combination? So if we are like, living on the earth more than 50 more years, no problem, you can use something. If we more, this world continue 100 more years, so this can use this connotation, no problem, because the combination is too high. So that's why, the sixth version is more likely providing a flexibility, more IP addresses, and this is more advanced IP addresses. So this is a simple thing. I know you got it now. Why IP6? Why they brought IP6 version? That's it. Yeah. This is all this latest thing like this, and this can give just combination of 4.3 billion. This can give a massive, massive, like enormous things here. There's some differences as well. So IPv6 is, I'm not going to tell you, so you don't need to worry. This is just a representation, their IP address. Once you snipe the packet, I would say please try to use Wireshark. In first practical, there was some Wireshark packet sniping. Try to use Wireshark and try to research it, analyze the packets. Maybe YouTube, maybe Google, all the referee you can check. Then you can analyze them with pictorial form, visualization form, so you can find what are the headers, what are these things, what all these things. I know there will be more than thousands technology you will find it, but more likely you will understand how internet is working, like encapsulation, de-encapsulation, time to live, hop count, protocol, IP addresses, everything, sources, destination, everything you will find over there. This is just a representation of IPv6 core, yeah. And this is a representation of IPv6 where, header is optional. So this is fixed header and this is optional always. So they have like, the destination, all these things almost similar, but this gives a lots of combination, yeah. So if you apply 2 to power to 120, it's more than enough, yeah. So let's say transport layer. We discuss, transport is all about TCP UDP, and make sure transport is all about the ports as well. Maybe I can tell you, the internet ports. So this is very important. Whenever you are connecting anything, whenever you are searching anything, let's say, so you type youtube.com or bbc.com. So this is just, the web pages. So whenever you are hitting the web pages, HTTPS. So we are using maybe, TCP connection. Maybe we are using some HTTPS, something like this. So always we are using these things. So once we enter youtube.com, bbc.com, this port is directly going after application to transport layer. The transport layer is saying, okay, this guy needs a browser from the server. So what they will do, so these ports are always open, 80 ports with the internet. Once we have internet like this, so this is open, so it will send the traffic from this ports to this transport layer, something like this. Yeah. These are the ports like internets communicate with the ports. So this is not just IP address, this is not just TCP UP, this is not just routing. Internet uses plenty things and technologies. So IP addresses with the ports, which ports they are going to use. Some ports they are by default they are open, some port they are not open, so these are closed based on the security thing. But there are more than these ports, 65,000 plus ports available within internet communication. So different ports, TCP is different, HTTP is different. There are lots of command line you can check. Linux, Unix, or you can even check on Windows as well, very easy way. So please make sure the ports are very important there. If you, let's say I apply like uws.ola, so maybe HTTPS. So I'm using port number 8 here. If I need to download anything, so maybe TCP connection, maybe I will use some, 443 communication, something like this. So this is a port. So always they are working inside the communication. The ports plays very important role, not just for TCP UDP, for more like all the client server architecture. This is very simple example. Let's say, so you are using this PC, let's say, just a minute, sorry, yeah. I have a flu today. Let's say you are using this PC browser and this is your class C IP addresses. Can you check it? And definitely you have plenty of ports as well, like we discussed. 1027, forget about, maybe you are using 80, maybe you are using 43 or 443, plenty thing. 23, 25. Let's say you say, okay, I want to watch this server YouTube. So you say www.youtube.com. What you are going to do, this is IP address of the server, 2.201.66.43.12. So you have to just say youtube.com, but your communication is using this IP addresses too. 201 something like, so from to here to here. So they are using IP addresses and they are using this port to communicate with each other. So this guy enter this youtube.com, so this will be translated from your networking technology. Once the server will send back to you, so it will send to your IP addresses. Can you check? This is your IP class C and this is on the port number 25. So it's sending from 25. Internet is communicating with based on IP addresses and ports number available on networking. Very simple. So these are configured within the routers thing. So I will show you later on. Yeah. So communication is made possible like this, IP and ports number, TCP, UDP, whatever you are using it. So I would suggest if you are making coursework too, so please, why not you are making something like this systematic drawing. So please give us some notation, some notifications, some systematic representation, how you are doing, what you are doing, which IP you are using. If you can give something, I know you are using packet tracer, but please try to use some draw.io for this representation as well. It will give you very good number of marks, so it will be very sufficient. Please check that. But to say, check the sample on frequently asked questions I have provided there. So let's say in TCP, sorry, internet model, so application. So last time, the first week we started, the application layer, the top level, so level number 7 on OSI model. But in this one, so this is number 5th levels, yeah, and this is level number 1. So more like in application, what we are going to do it. So we are just using internet browser application, any user. So let's say you say www.youtube.com, www.bbc.co.uk. So we are just consuming, we are just utilizing, HTTP and data only. Simple. Once we are coming to the transports layer, now let's say you say youtube.com. So this is going to be converted inside of different source and destination ports. Let's say you want to open TCP port, but which port? Source or destination, like we did it. So in transport, so they are using ports where they are segmenting the destination in sources. So this is source, this is destination. Once this server is sending to you, now this is destination, this is source. So always they are making connection like this one. Yep. Once this is going to the network layer, what will happen? So this is going to be converted in routing tables in logical IP addresses. Let's say you type youtube.com, it has applied with TCP UDP ports, then it was converted and applied with different source and destination IP addresses. And on the data link layer, the physical layer, so what happened? So, network interface card we discussed before, they are applying, the physical addresses, the real addresses of your network device, like Wi-Fi devices. After network devices, so we are connected on internet or maybe cable, then they are transmitting on physical medium, internet service provider, maybe your cable, maybe your Wi-Fi access, that's it. So this is where the network layers always works across them. So let me finish because I can't speak too much. So this is just function in transport layer. So it's segmentation. Segmentation is very simple. Let's say you have a very massive amount of data. Let's say you are using, the maybe the stress test, maybe 4K video. So this means so we are using very massive amount of data on our internet browser. So what will happen? The data cannot be, maybe our internet is very slow, maybe our service is very slow. They cannot support these things. So what will happen? The transport layer is dividing these to heavy traffic into the segment. Why? Because if we break the traffic, let's say this is very big traffic. Now it is making like small kinds of packets like this, so small segmentation. Then it's going to transfer from sometime, the size depends on the network, upstream, downstream, maybe, bandwidth, maybe your latency, maybe your breakthrough, all these things. Sometimes, the maximum size is negotiable, depends like, some size is not transferable to internet. So what will happen? So they are trying to negotiate which traffic has to go first and which traffic has to wait. So after segmentation, they are just transferring. Simply a segmentation is a rule of breaking larger file into smaller. Why? Because it should be easy to transfer on internet, either cheap internet, either slower internet. That's such a maybe I will ask some question like this way. That what is a segmentation? You don't need to write, but you need to select a good points from the bottom line. That's it. Okay, guys. So please be careful. So there will be some question. This is just formula 1500 bytes TCP 20 IP 20. So you will get kind of header. So this is just I'm not giving this in class tip. So this is like sender receiver. Once the packets once the data is transferring on application, this is known as a packet. If I'm asking the representation of data on network and application layers is a packet, true or false, so you need to say yes, because packets, they are in the form on application, they are in the form on network layer. If I'm saying transport is using segmentation, the segments of the traffic. Data like using RAM, something like that. So you need to just think about it. So these are very simple questions when it comes across it. Or let's say it's very important, the addresses. So, address is very, very important. Let's say once we are connected internet, let me go to you. Let's say we are connected right now. London campus is connected with all Europe, Central Asian, African, Eastern Europe, all the countries. So what is the logic behind it? We are using a routing addresses. Maybe this autonomous router is in London, maybe this is in London, maybe this is France, maybe this is in Spain, somewhere like, connected. Autonomous networks, they are connected. So how they are connected? They are using different, the logical addresses. Sorry if you can mute. So these are just logical addresses. So source to destination. This is source, this is destination, this is destination, this is source. This can be anyone can be source, anyone can be destination. Let's talk about the sources now. Oh, sorry, addresses. Yeah. So addresses is like, it is used to direct messages or send the data from one source to another source. So we can say from source to destination networking. Yeah. So address is being used. So make sure whenever you are communicating, so they are using different addresses. This is from source, this is destination. If I want to send any message from Europe to Central Asia, what will happen? I have to utilize the major address of the Central Asian autonomous system. So rather than they will never go to like this and this, all this thing. They will just follow the routing tables. Okay, Asia is connected this one. That's if you want to connect Europe, they say, okay, Europe is connected this one. So this is the logical addresses, okay? Very simple. So routing, so we are going to configure them in Cisco base, in Juniper base, in different things. Where is the thing? I think this is okay, so we were here, so we did this thing. Okay, I think we didn't do it. So let me finish address, then I'm coming here. Yeah. Address is like, direct message from one to another source, so source to destination. Yeah. So once we write any addresses on YouTube, or sorry, on browser, so this means that youtube.com, bbc.com, there are some resolutions, there are some domain names server, there are some address resolution protocol. They are just trying to convert. So normally we are entering this thing, but this is not happening. They are converting into form of IP addresses. So this is the addressing contents. So they are doing it, yeah. And this is, oh, sorry, I missed it, so I'm going to back a little bit, yeah. And this is session management. In transport layer, we are managing the session. As I say, TCP, UDP before. Whenever you are requesting any TCP content from the server or you are sending any reliable content towards the server, make sure transport layer is creating a permanent session for them. So we say connection oriented mean a session is created, which says sync, acknowledgement. Yeah. So they are just making a session, temporary logical circuit, the virtual circuit we can say. Circuit is a like, pathways for communication. If you have like, let's say this is your light bulb connected on internet, sorry, on the electricity. Okay, let's say this is load line one. So we say live. Okay, we say this is neutral and this is light. So neutral is always connected to your light bulb. And neutral and light source is not connected. So once you are pressing the switch, so what will happen? So light is passing towards the circuit. So this gives a complete path. Once you turn on the switch, the light is glow. The light is working. Once you turn on the switch, your fan is working. This means so we are giving circuits pathways. So both in the electricity connection is going toward electrical appliance. Then these are working. So we say this circuit. Again, in the TCP, so TCP's connection session is making a virtual circuit as well. Circuit means, let's say you are a sender and this is receiver, server, sender, sender, server. So you are syncing, sync acknowledgement, acknowledgement. So we say something like this. So this is temporary virtual circuit. It's happening. And that's why we say the transport layer segmenting things. And this is doing this mention, sorry, what to say is as a virtual circuit session management as well. So please make sure there will be a question in your class test. I hope so you're done with addresses, very simple. And this is network layer addresses. So very simple. Addresses are most commonly written in the dotted decimal notation. Dotted decimal. Whenever you are writing address, so make sure you know dot 129.79.78.197. We say you know the dotted decimal. And each decimal is represented like you know the octet byte. One is octet, another octet. Octet means so you can say this is octet one, this is another octet. This is just IP addresses. Yeah. In our books, so we are writing like this, but in communication they are converting digital IP addresses, ones and zeros only. Just a minute, so you have a fill.
Sir, you are on mute.
Sorry, yeah, I muted because I have a fill. Okay, guys, thank you so much. So I think this is dotted notation, and this is just representation of IP addresses. So if you can check, you know, IP has a different classes, class A, class B, class C. So this is private address, and in public, so might be A, B, C, D, E, and is different. Yeah. Normally, our computer, our simple experimental thing, so we are using class C. 192, something like this. Yeah, either private or either public. So we are concerned, we are using more like inside our PC's configuration. Yeah. So class C, why we say class C, why we say class C, A, B, C, D, there are different ranges, you know. So IP address is a some session. Let's say, okay, we are talking about it. In class C IP addresses, maybe we can say the first three digits, they are the network representation. Last one is a hosting. Maybe in other class, so they are like, you know, 50-50, depends. One is two for this, two for network, two for host, something. A maybe, you know, three for network, one for the host, just depends. So IP is different. So someone is used for this one and someone can be used for experimental thing, important things. So it depends that. These are just representation. Okay, guys. So I will show you. A private IP is like, you know, whenever you are privately connection, you're doing a connection inside a private network under your control. We say a local area network or into your premises, a proprietary services, we can say. A public IP which can be accessible, can be usable to one users to any one user out of internet. Yeah. If we say public, so this can be used, can be outside of internet. Network address translator, what does it do? The net translator, let's say this is our Wi-Fi router. Can you check? One student IP was, you know, 192.168.0.1. So this is like, you know, first three digits are network, last one is host. So here can you check 192.168.0? This is same, this is same. Three digits are same, octets are same. The last one is changing 1, 2, 3. So we can add different user. So they are connected in the one Wi-Fi server. So what network address is doing? They are collecting a lots of logical addresses like you know numerous address, then that's kind of transmissions to one internet. This is happening whenever you are coming to utilize your Wi-Fi routers. A network address translator is giving you and taking your IP address, then sending to the one line of internet. Like we discussed, you know, the multiplexer. So this is kind of the same thing, the network address translator taking various IP and then sending all as a one combination into the network to communicate where and wherever you wanted. That's it. Yeah. So let's see, very simple. So address is the same thing, you know, we discuss. They are giving their sources and destination. They have kind of, you know, different class or addresses as well, number of hosts. So make sure whenever we are using IP addresses, so we have a subnet mask. So we say CIDR, the last less interdomain routing. Let's say if we are using class C IP addresses, so 192.168.168 anything at the end, 0 dot anything at the end. So this might have 255.255.255.0 is a CIDR mask. So classless interdomain routing. Any IP addresses, so they are networking things, they are converting the host bits to 0 and 1 bits as the network bit, something like that. So this is the subnet mask. So whenever you are using IP, you might face it, you won't find it here. I know it's a bit technical, but once you experience it, so you need to know, especially in the Wireshark. Yeah. So this is class C, as we say, 192. I said, 192.168.0. We said 3 bits are network. Can you check the first 3 bits are network? And last bits we are using maybe 1, maybe 2, maybe 3, up to 255. So we can make up to 255 addresses with this class C IP addresses. So please make sure this is just representation class A, class B. Every IP is different. And dynamic IP addresses is something different. So let me show you. Let's say let's say we have 1,000 students, they are coming to our campuses every day, especially for BDCN in London and Paisley campuses. So what will happen? UWS. Do you think the UWS is giving 1,000 IP addresses to all students manually? No. Our server, they are not giving. Our router, they are not giving manual IP. It's time consuming. A dynamic addresses is working there. Whenever the student they are coming, a dynamic IP is assigned to all of the students once they are connected. Yeah. So this is just dynamic. Static is very, very old fashioned. Nothing is working now. So that's why, dynamic is always working. Like you can check the network address translator. So this guy, so there are some kind of DHCP server. So what they are going to do, so let's say the one guy entered as a student, it will give some 0.1. If another student is coming, it says 0.2 and like this. So they are giving different IP address to everyone. Yeah. So we said this is a DHCP, dynamic host configuration protocol, DHCP. So please make sure. It's very simple. Sorry, if you can mute your microphone, let me finish. So network layer, so address resolution protocol, this is again same thing. Once you type, indiana.youtube.com, what will happen? So on the application layer, so our cookies, our web browser, web server, they are trying to convert in IP addresses, identifiable, just to be reaching, the main server. As I said, everything on internet is the IP address, logical address, and port number. Whenever you are typing anything, so it's going to be converted in IP addresses. Whenever IP is converted, they are going to be represented in digital bits and bytes. That's it. So this is the way client is reaching, I want this, I want this. This is just client server architecture. So let me think about it and finish this thing. So routing is like, process of identifying, providing the path for packets to pass through a network from sender to receiver. Let's say anyone can be sender, anyone can be receiver here. So they want a path now to receive and send a packet. So this is called about the routing. And what does the routing mean? So can you check? This is routing table. So we say this PC is using this algorithm, maybe BJP, maybe EIRP, maybe autonomous system. They are using different paths, like this path, source, destination, something like this. Yeah. So we said this is all about the addresses, routing addresses. Yeah. And routing addresses, these are the logical decisions. So they are following which path is a suitable, which path is a optimal, which path has the longest distance. So there are different paths. So we can check A, B, E, A, B, C, E. So this guy can reach from here to here as well. This guy can reach from here, then here as well. But this is not optimal. So it depends. So routing path provide optimal sticks, okay, efficiency. Yeah. So routing means the providing path from source to destination. Routing tables mean the logical decision thing to minimize the efforts to reduce the workload. And what are the routers? I know the routers, so might be you have seen, routers are different things. No, never. If you have checked, the Cisco routers, so routers are almost the same thing like your PC, like your motherboard. If if you open any routers, the router has the same processor. If you buy any router, so your PC, your laptop, you say no, routers are different. Your PC is different. Never, everything is similar in network communication. But what's the difference in router? So let me clearly show you. You know, your PC, let's say you can check very high quality, high fidelity screen resolution, a good audio, good video. But this is not possible in router because routers are special devices. They have processor, they have RAM, they have calculation, they have arithmetic, logical, and everything. The motherboard is almost similar. There is no difference. Just one thing I can show you now. Sorry, Epic. So let's say this is motherboard of your PC, this is motherboard of router. So they have route processor, they have random access memory, they have power supply, Just your PC has a video graphic, they have very good, multimedia audio, and router they don't have VGA and audio graphics thing. Why? Because they are used for the processing traffic. They are used for multitasking, but these are again PC. They are again computer. Router is a computer. Your laptop is a computer. They almost the things in operation are similar, but they are designed to transfer and receive the traffic. Routers are designed to receive and transfer the packets, provide the parts. But your PCs are designed to work on audio, video, and internet thing, everything. So that's why they are using, video graphic adapters, kind of, audio, video peripherals, but they don't have. This is only different. They don't have audio, video connection. That's such. Otherwise, the routers are kind of processor, computers, something similar. No problem. They are almost similar. I think so. Routers. So these are the routers are special devices to make internet possible to handle routing all these things. So these are the routers, let's say they are connecting with the routing tables. These are, I say, just designed to transfer and receive the packets. So this guy can reach from here to here, they can reach from here to here, but depends which algorithm, which routing tables you are using. So they are following the same techniques. And make sure once internet, the routers are not pre-configured. The engineers are supposed to configure them. So they are applying configuration. If it's Cisco, they are applying Cisco configuration. If this is Juniper networking, so they are applying Juniper connection. If it's IBM connection, so they are applying IBM connection. It depends which hardware you are using, which company they are using. So they are configuring according to their configuration rules and regulation. That's it. They are not just Cisco. They are multiple companies. They are working together as an autonomous with the. Okay, guys, so this is just a representation. Don't worry. So this route internet is connected with multiple autonomous system. They are connecting like this. So I discuss, so I'm not wasting your time. The internet, so let's say these can communicate with any interface. So these number of 1 to 3, these are interfaces. Whenever you are using any router, so they have different interfaces. You can check the interface 1, interface 2, interface 3, 4. More like they have lot GH01 and 011. They have two interfaces. Sometimes they have more than two interfaces. So there's their 4 connections here. So centralized and decentralized, very simple. Centralized means very old ones, once was being configured with the one PC. Decentralized, right now we are using it. So we are not going to configure anything. This is pre-configured from the company. Maybe London routing is based Cisco. Maybe, the Asian European routers are based with IBM and Juniper. So they are pre-configured. We don't need to do anything. They are decentralized. That's it. Okay, guys, let me finish. And static is all about, the fixed things. So fixed things, so we cannot change them. So this is very old. Manually, so they are going to be done. They need to add manually. They need to remove manually. Dynamic, we say, everything is adaptive. Let's say this is our internet from London to Europe. Let's say you just moved in London recently. What will happen? And you want a connection from over here. What will happen? So you are connected in this part, automatically it will assign some IP address to your home internet. That's it. So we say this is adaptive things here. So routers are going to be connected with adaptive things here. So not, okay, where is this thing? Okay, so this is all about this thing. Now let's finish this thing. Centralized, decentralized, and this is adaptive. Adaptive means whenever new guy is coming, new internet connection is connected. So this is giving automatic connection without any troubles. Sorry, I have a flu. Maybe I need to finish quickly. A distance vector and link step. This, I know this is very technical, but I will finish very soon. Distance vectors, numbers of hope. Make sure that how many neighbors are connected, number of hopes, like you have neighbors. Let's say if I say this router has different hopes, like 1, 2, 3 hopes here. So distance vector is being used with the number of hopes here. And link state is all about, number of hop, but it's based on the speed. Let's say this guy has again three hops, 1, 2, 3, but the which speed is a better, like maybe this speed is better, this is shortest distance. So they are just different connection. Link state is based on the speed and distance vector is just based on the hops to the neighbors. That's it. Yeah. So let's talk about the routing information protocol. This is just an example of protocol. We are not doing any configuration, but there is lots of configuration. RIP routing configuration. If you do it, let's say RIP routing configuration. If you find it, so you are supposed to do like, routing information protocol configuration like this here, router version, all these things. So you need to configure it. Interface, apply global connection, apply all these things, reset these things. So you are going to do like, these versions of routing tables. So in Cisco, you are supposed to configure with, party connection or directly interface connection. So you can configure, yeah. So simply, this is just protocol. I'm not going to do it and we are not going to do it. But why? Because it's non-IT student. Yeah. This is part of dynamic distance vector. And this is like, working especially for smaller and less complex network because of older technology and very slower speed. So we are using it here. If we are using open shortest path, OSPF, open shortest path, this means this is very good routing protocol which can be used in a massive networking connection. Once we have lots of networking, so we can use OSPF as one of the famous networking protocol. So which always follow. Let's say I am here now. I want to reach here. So what I will do, I will not use all routings. They are connected. So I will use the shortest path, which is the shortest path is this way. So open shortest path is always following the optimalistic and the one of the closest path. That's it. But there is a configuration as well. So let me show you. So you have to say OSPF protocol. So you can check in OSPF can be configured in terminal mode like this one. So you are supposed to do, there are different things. So you are supposed to configure your routers can be connected. I'm not doing, I'm just telling you. And this is a link state protocol. Why? Link state, I say this is dynamic and link state always following the best and fast and the closest path. That's it. Yeah. And this is EIRP, enhanced interior. So example, I'm not showing you. Let me show you the BGP. Maybe a border gateway protocol is one of the important protocols. Without BGP, I don't think so internet is possible. Let's say you are using WhatsApp. Let's say you are using Facebook. You are sending money to family, receiving money from your family. Everything, whatever you are doing and which parts you are belonging to, no problem. Our entire internet is based on autonomous system. Let me clear this thing. Autonomous means, let's say, from India, they are using different internet routers, from Pakistan, from Africa, from Europe. Everyone is using different autonomous systems, ISP, maybe different. So what they are doing, this is Cisco, this is HP, this is Juniper. Now BJP, like, it's not a protocol inside your city. So BJP is connection with, city to city, content to content like this. Yeah. So one autonomous is another autonomous. Let's say this is Cisco, this is Juniper. They are connected with the BGP border gateway protocol. And they are using, the labeling switches. On the edge connection, they are using a multi-protocol label switches. BGP is going to connect them. If we don't have BGP, so what will happen? The border gateway protocol. So we cannot connect Europe to America. We cannot connect Asia to Europe. Something is not possible. So that's why BGP is a border level protocol. Border to border connection is possible with the BGP. And again, BGP is the same configuration. If you go and check, it is a dynamic distance vector and more complex, and it is very, very, preferable, more likely in use right now. So they are using BGP. If you can find it, so you will find everything there. Yeah. So this is just routing information. We are not concerned and we are not supposed to do it here. So BGP and OSP all together. If you want to design a networking topology, so you can configure. Let's say first you need to create a logical, a graphical representation. Like you can say this router will connect this thing, or mesh topology, and you say this is going to connect with fiber optic, something like so. Then you are going to apply, OSPF and BGP connection all together. So this is a configuration, this connection engineers are, they are doing it in nature. OAP pre-train. And you can do this in packet tracer as well, like this. It's very easy. Yeah. Okay, guys, so I have some few problem. Maybe I can't. Multicasting, broadcasting, unicasting, very simple. Unicasting means one-to-one computer inside the local, very simple level. Broadcast means, the amplitude modulation, like BBC. Once you are far away on the road, you're listening the radio. It is all about the broadcasted radio. So you are listening a broadcasted radio. So we say one computer to all computer inside the London, inside the Europe, wherever you are, you can read and listen the things. A multicast, so it's all about like, let's say we are in the multicasting now in a team. So I have given you a link to more than 500 students. They are joining me. We say this is multicasting. It's just all about, just limited language intake. A broadcast means anyone in the city, anyone in the country. Unicast means one-to-one. That's it. I think we are almost done. So let me finish. Okay, TCP/IP, this is same thing. We have default gateway. So all the way, let's say this one network, you apply IP address. So here you will apply a one default gateway to communicate. So I'm just letting you know. At DNS server, the same thing we discussed, converting from IP to names. Guys, so I would say please make sure whenever you are writing coursework 2, this will be very important. Coursework 2 must be a network drawing, network topology. I would say you are working packet tracer, perfect, do it on packet tracer, but I would suggest please try to give a networking mapping, a network topology like this as well. So can you check it? A one router, we have used this IP address and this physical addresses. 192.198.1 dot third one, sorry, 128.192.98.130 at the end. Please, you need to create a level 1, level 3 flow routing. So you need to mention IP blocks like this one. Any IP, class A, class B, class C. I want you to represent some IP address in coursework 2 here. Whenever you are connecting a network things, all these things. So please draw things like this way. So this is clear example. You will get a good marks if you had. Can you check it? So this is internet. This is building 1. This is building 2. We are connecting. So let's say we say 30 PC here. So you can say 130, 131. So you can say 140 something like this. So we can say these are the 20 PC representation. So please try to add IP representation like this. You will get very good mark. Yeah. And TCP IP, host computer, gateway, router, these are very simple. I'm not going to discuss, very simple. What is host, what is gateway, what is router. And this is just, can you check how message is going through? Is starting, can you check the application layer? We just typed www.youtube.com. A HTTP request was just inserted. It's just kind of, the user experience interaction, like a web page, HTTPS. What is happening once it's passing from application to transport layer? So transport either is TCP, either is UDP. So it's just applying the ports number. TCP port is maybe 25, maybe 80 ports. So they are applying the ports here. In network layer, so network layer, then they are applying the IP addresses there. First it was just youtube.com, then applied the port number, then they are converting with the destination source IP address in network layer. In data link layer, we discussed last time frequency, wavelength, all these things. They are just trying to convert in all kind of bits and bytes. And physical layer, this is just representation of logical or digital signals just to pass on the cable. This is just a moving packets through the layers. Okay, guys, so I hope so you got it. So please, if you need any question, any discussion in more details, so I would say online may not be possible. So please feel free to meet me. Even we can make this networking possible with real lab as well. Let's say this is network, so we can make it possible without any problems. We can make a complete digital, sorry, a Cisco networking in our lab. We have got lab, so we can make configuration. If you want to learn more things, please let me know. Yeah. So what I'm doing now, let me take your attendance. I have a severe flu. Then I might stop soon today. So if you have any question, please let me know. Yeah. So let me take your attendance first. And please start work on your assessment now. Yeah. It's time to finish. How many? Any question, please?
This the audio recording. Where can we get it in all? I can't find it.
Audio recording, I'm not sure, we are recording it definitely. So it was working before. Right now, I don't know. The university has removed this thing or don't know. I will confirm with IT things. Yeah. But but if you want access this thing, maybe later on, once I finish, so I will share with you all of you. Right now, I am busy, so I will share with you personally.
Please, I need it.
Definitely, yeah. Anyone else, please?
Hello, sir.
Hello, yeah.
Hello, sir.
Uh,
Yes, please let me know.
Can
have
you
you
hear me now,
taken
sir?
the attendance test? Because I was disconnected at that time due to poor connection, so that's why I was
No
asking that.
problem. Anyone else, please let me know, yeah. Any more questions?
Can we leave, sir?
Yes, so I'm finishing. Almost done, so you can leave, please, yeah.
Okay, thank you so much, sir.
So if you have any question, let me know because I have a few, maybe I will close. Sorry, close. I would say everybody try to listen or try to everyone. So please try to work on your assessment. So I would suggest start working on your what to say the
Hello,
major
sir.
parts. Please try to work on the major parts of assignment. So I will leave them open on the assignment section now. Please make them work together, make your groups, all things must be ready and show your lecture on campus. Sorry, what was questions? Who was asking?
Hello.
Yes, please.
Can we do the assessment alone, or should we have to do that in group?
Sorry, can you repeat it again?
Sure. Do we have to do the assessment alone, or is that a group thing?
Yeah, right now you are not supposed to do, but I would say start working on your assessment. And once you are coming on campuses, so please try to get feedback from your lecturer. So this is the best time to improve your coursework. Improve coursework, finish your coursework, and get feedback from your lecturer on campuses. Yeah. And I will create links for you very soon and make sure the deadlines are already there. Maybe I will extend it, maybe I will not extend, depends on the university regulation. So please check the deadlines, they are coming soon, yeah. And please follow everything is there. So I'm closing now. Is there anything left? So maybe we can discuss later on.
Hi, sir. Can we discuss about the classworks like lab sessions as well here?
Lab session, if you can submit on folder, this will be better, please, yeah. If you are working alone, just say this is group coursework, otherwise say this is solo submission.
Like I was working on it, but I had some questions regarding that. So
Yeah, you can
I
ask,
want.
you can meet me on Friday if you are coming. If you have any questions, you can meet me on Friday. You can just let me know, I will help you, don't worry. Lab things, just email me, I can help you, don't worry.
Okay, sir. But just it's shall I have to like book a session with you for meeting with you in Friday,
Oh,
coming Friday?
Friday, no need to book a session. Just, come to classroom, inside classroom from 1 to 5 o'clock in Port Building, classroom 1 and 2, yeah.
Um, which classroom, sir?
A classroom 1 and 2 in Port Building.
Import building. Okay, sir.
Yeah.
Thank
Anyone,
you.
you can come and discuss any problem, any issue, even master's project, even your networking thing, even anything else. So I will be here to help you. Don't worry on Friday. Yeah?
Yeah, thank you, sir.
No problem. Okay, everyone. So I'm leaving because I have a flu. And thank you so much for your all cooperation. And hopefully, so you are working on assessment. So please work on it and show your lecturer. So if there is any question, and I will discuss with you in coming lecture. And please make sure you need to work on your all these things we discuss. Coursework 1, coursework 2, and class test. I will show you later on the main thing what you do. But I would suggest the first few lectures, like the application up to transport, maybe first 7 to 8 lecture, they will be very, very important for your class test questioning. So if you want to get